Dipole antenna with resonance frequency 0.9 GHz. And after designing the dipole antenna, we will see how we can add the sweep and how we can shift the band from 0.9 GHz to 1 GHz to 0.8 GHz to 0.85 GHz. First of all, add some parameters. Length of this dipole will be 128 mm, radius 3 mm, similarly gap 20 mm, and input impedance is 70. Draw a rectangle for this much dimension, radius and length along z-axis, and select material copper. Similarly, draw another cylinder so that we can create a gap between the arms of dipole whose dimensions are outer radius will be same and change will be the length along z-axis. Similarly, take material copper. After that, you have to subtract dipole. You have to subtract the gap from dipole. The antenna would be like this. After that, we will assign a port which is discrete port. For that purpose, you have to select the face, this face, pick the center point of this, and similarly rotate and pick the center point of this. And similarly just add discrete port. After that, select the frequency range from 0 to 2 and add monitor field, E field and far field. Yes. After doing this, press OK and add these fields and analyze the project by using this application, and you will see these results. This is the result of this much dimension of a dipole antenna. Here you can see that it is giving us exactly a 0.9 GHz. Resonance frequency is 0.9 GHz. If I add the sweep in a length of this dipole, if I going to edit it from 125 to 175 mm with a sample of 10, the result will be like this. The operating frequency band will shift along 0.9 GHz adjacent frequencies at 0.85 GHz. Similarly, now let's check the different peak frequencies. This is peak frequency we have. .7 gigahertz, 79 gigahertz. Similarly, at 0.92 gigahertz. In this way, we can shift the band at the frequency on which we want for our application. If you want to know the basic concept how the bands get shifted, you can check this on my channel of dipole antenna series, where I have explained the basic concept, theoretical concept, how the band is shifted, how the band can increase their bandwidth, how we can increase the gain of antenna, and how to measure the front to back ratio. Similarly, we will see how to choose and finalize the input impedance value for best matching position.